electricity in motion. And this in fact became the foundation of the special theory of relativity. But this is what was made precise actually in 1860 by Maxwell. This is Maxwell, one of the great physicists of all time, using these equations, which are very similar to Maxwell's equations that he wrote down. So I'm now going to switch to my other theme. So if there are any questions from the students, please feel free to ask. Or should we take the questions in the end? Okay.
Okay, I have this.
Yeah, maybe we can keep the shorter questions now and longer questions later.
Okay, so whenever people are trying to unify different theories, so how and they know from the experiments how these particles or interactions behave. So how do they pick up the right mathematical formulation or framework which might explain the different interactions and the phenomenon?
Yeah, I mean, if I had a answer to that question, I would have several number of answers.
But you studied like your focus is on unifications.
So I will tell you how my generation is doing it towards the end of the talk. I mean, there are usually it doesn't start by looking at the data, but you need some bigger idea, which is actually not part of the data. Otherwise, like Maxwell, right? He had to write down some equations. He had to invent a whole mathematical structure to put known laws into some framework, and then he discovered some new phenomena. So usually it's a process of struggling with what we know and imagining what could be. But it's a very constrained kind of imagination. It's not like an imagination of a painter where you can paint whatever you want. You have to paint what is consistent with what you know. And that's a much harder kind of creativity. And there is no simple answer to your question.
Just a quick question.
Remember it exactly, but he said that nobody in a possession of his faculty of of thought would believe in this absurd proposition that if I wave my hand, the moon gets affected, right? Because that's what Newton's law says. So Newton actually understood that there was something wrong with his assumption. How could something action at a distance instantaneously? But he wisely kind of made a research tactical decision to postpone this resolution of this puzzle for future. Energy that is unbelievably large. You cannot imagine. It's much larger than the energy of all the stars for that fraction of a second. But it is all in gravitational waves. Nothing is visible. And this is what happens. And these little dots are actually stars around these black holes. This is how it will look to you if you were nearby the black holes, because they